Residential sprinklers are the primary choice for protecting homes and other residential occupancies. These sprinklers use fast response elements and are designed to provide greater wall wetting coverage compared to standard spray sprinklers. This enhanced performance helps control a fire more quickly, improves tenability, and ultimately increases the chances of life safety and successful occupant escape. In this video, we'll take a closer look at residential sprinklers, how they're designed and why they perform differently from standard spray sprinklers. We'll also walk through the hydraulic calculation requirements, following the criteria in NFPA 13D, 13R, and 13. It should be noted that the installation rules for residential sprinklers are almost the same as those for standard spray sprinklers, with only minor differences, so we won't cover them in this video. If you want to learn more about these requirements, you can watch the videos in the Installation Rules playlist on the 𝐓𝐨𝐩𝐬𝐢𝐜 YouTube channel. One of the biggest differences between residential and standard spray sprinklers lies in how their coverage area is determined. Before delving deeper into this distinction, let's explore the general relationship between pressure and sprinkler coverage as observed during performance testing. For all types of sprinklers, including standard spray, extended coverage, ESFR, CMSA, and residential, the actual coverage area is influenced by the available water pressure. According to Chapter 1, Section 16 of the 21st edition of the Fire Protection Handbook, a pendant spray sprinkler with a K factor of 5.6 installed 8 feet above the floor has a coverage area of 254 square feet at 7 pounds per square inch. When the pressure increases to 70 pounds per square inch, this coverage area expands to 530 square feet. Interestingly, at higher pressures, the coverage area begins to shrink. For instance, at 175 pounds per square inch, it reduces to 170 square feet. This phenomenon occurs because higher pressures produce smaller water droplets, which are less able to overcome air resistance and thus cannot be thrown as far. As we reviewed in earlier videos, NFPA 13 determines the maximum coverage area for standard spray sprinklers based on the occupancy's hazard classification, regardless of the available pressure. Residential sprinklers, however, work differently. Their allowable coverage area depends on the available water pressure and must follow the specific performance data provided in the manufacturer's datasheet. The coverage area for upright and pendant residential sprinklers is square, with listings commonly available for 12 by 12, 14 by 14, 16 by 16, 18 by 18, and 20 by 20 feet. Residential sidewall sprinklers, on the other hand, may be listed for square or rectangular coverage areas, including 12 by 12, 14 by 14, 16 by 16, 16 by 18, 16 by 20, 18 by 18, and 18 by 20 feet. It's important to note that the listed spacing of sprinklers must be in even dimensions, and the maximum coverage area not exceeds 400 square feet. As long as the manufacturer follows these requirements, they can list sidewall sprinklers with other coverage areas, such as 16 by 24 feet. Let's return to the relationship between pressure and the coverage area of residential sprinklers. Let's look at a hypothetical model of a pendant sprinkler specification table, similar to the tables found in the data sheets of reputable brands such as Tyco, Viking, or Victaulic. Based on this table, if 16.7 pounds per square inch is provided, the sprinkler can cover an area of 20 by 20 feet, while a pressure of 12 pounds per square inch allows coverage of 18 by 18 feet. It is interesting that for coverage areas of 16 by 16, 14 by 14, and 12 by 12 feet, the minimum required pressure is listed as 7 pounds per square inch. This is because the standard specifies 7 pounds per square inch as the minimum operating pressure for sprinklers. Although testing may show that these coverage areas could be achieved with lower pressures, the standard's minimum pressure requirement is why 7 pounds per square inch appears in the table. When selecting the minimum required pressure for a sprinkler, the larger dimension of the area to be covered should be considered. For example, if a pendant residential sprinkler is installed at the center of a 16 by 20 foot room, the minimum required pressure should be based on the 20-foot dimension. In other words, the pressure required for a 20 by 20 foot sprinkler coverage. Regarding the pressure required for sprinklers based on the datasheet, we can generally say that the required pressure for upright and pendant sprinklers is lower than for sidewall sprinklers for the same coverage area. For example, when using a pendant residential sprinkler to cover a 18 by 18 foot room, the required pressure is 12 pounds per square inch. However, for sidewall sprinklers covering the same area, the required pressure increases to 22 pounds per square inch. Therefore, when conditions allow the installation of pendant sprinklers, for example, when the room has a suspended ceiling that conceals the piping for aesthetic reasons, choosing pendant sprinklers in the design can be a better option than sidewall sprinklers from a pressure requirement standpoint. As we've seen in this section, residential sprinklers can cover a larger area than standard spray sprinklers. Therefore, using them can reduce the number of sprinklers and the amount of piping required. For example, in a 20 by 20 foot residential room that would require 4 standard spray sprinklers, only 1 residential sprinkler may be needed, provided that the required pressure is available. In the next section, we will see how residential sprinklers can also reduce the required flow and pressure of the system. In 1- and 2-family dwellings and manufactured homes, residential sprinklers shall be used in accordance with NFPA 13D. However, in certain spaces, such as mechanical closets, saunas, steam rooms, or unheated areas not intended for living purposes, quick-response sprinklers are permitted instead. For hydraulic calculations, the design area includes all sprinklers within a compartment, up to a maximum of 2 sprinklers that create the greatest hydraulic demand. The compartment has its own definition, which we already explained in the small room rule video. In the first figure, only 1 residential pendant sprinkler is installed, so the hydraulic calculation is based solely on that sprinkler. In the second figure, there are 2 sprinklers in the compartment, meaning both must be included in the calculation. In the final figure, there are 3 sprinklers in the compartment. However, we only need to consider the 2 sprinklers that create the greatest hydraulic demand. Regarding sprinkler flow in hydraulic calculations, the standard states that the system shall provide at least the flow required to produce a minimum discharge density of 0.05 gallons per minute per square foot, or the sprinkler listing, whichever is greater. However, this minimum density of 0.05 gallons per minute per square foot is not the design requirement for the hydraulic calculation of an NFPA 13D system. Instead, it is a benchmark intended for manufacturers and listing laboratories to ensure their sprinklers discharge enough water to control a residential fire. Therefore, when performing our hydraulic calculations, we only need to apply the sprinkler flow based on the coverage area and the available pressure specified in the manufacturer's datasheet. In this example, there are 3 compartments. If we assume each sprinkler has a coverage area of 20 by 20 feet, the system demand should be determined by performing the hydraulic calculation for the 2 sprinklers in compartment 3, as these sprinklers create the greatest hydraulic demand. In the hydraulic calculation to determine the system demand, the most remote sprinkler is sprinkler 101. At this node, we should consider a flow of 20 gallons per minute and a pressure of 16.7 pounds per square inch in accordance with the sprinkler datasheet being used. The next steps are similar to those we explored in the previous videos. NFPA 13R requires residential sprinklers to be installed inside dwelling units and also permits their installation in certain areas, such as lobbies, not in hotels and motels, foyers, and corridors. This standard also permits the use of quick response sprinklers in dwelling units that meet the compartment definition, provided no more than 4 sprinklers are installed within the dwelling unit. This provision is commonly referred to as the hotel room exception because it is most often applied to hotel rooms. For hydraulic calculations, the design area includes all sprinklers within a compartment, up to a maximum of 4, that create the greatest hydraulic demand. When selecting the 4 sprinklers, it should be noted that they must be adjacent to each other. In a large compartment with more than 4 sprinklers, it is not necessary to pick the 4 most demanding sprinklers regardless of location. Instead, the 4 sprinklers that are adjacent to each other and together make up the most demanding combination of 4 adjacent sprinklers are chosen. In this figure, the coverage area of sprinklers 1, 2, 5, and 6 is 20 by 20 feet, while sprinklers 3 and 4 cover 14 by 14 feet. When selecting the sprinklers for the design area, we should choose sprinklers 3, 4, 5, and 6 because they are adjacent to each other and are located farther from the water supply, resulting in a greater hydraulic demand. In other words, we should not select sprinklers 1, 2, 5, and 6, even though they cover a larger area. Similar to NFPA 13D, when performing the hydraulic calculations, we only need to apply the sprinkler flow based on the coverage area and the minimum pressure specified in the manufacturer's datasheet. In accordance with NFPA 13, residential or quick response sprinklers are permitted for use in residential occupancies. Unlike NFPA 13D and 13R, hydraulic calculations under NFPA 13 must consider 4 adjacent sprinklers that produce the greatest hydraulic demand, regardless of whether they are located within a single compartment. In this figure, many combinations of sprinklers would need to be evaluated to determine which is the most demanding. It is worth noting for all 3 standards that when performing hydraulic calculations, one combination might be more demanding in terms of flow, while a different combination might be more demanding in terms of pressure. When this occurs, both combinations are considered most demanding, and the water supply must be capable of handling each one individually rather than both combined. What makes hydraulic calculations more interesting or sometimes more complicated is determining the minimum flow of each sprinkler in the design area. Section 19313 states that the minimum sprinkler flow must be the greater of the flow indicated in the manufacturer's datasheet, or the flow calculated by multiplying the density of 0.1 gallons per minute per square foot by the sprinkler coverage area using the S times L method. Where the room or compartment does not exceed 800 square feet, the average coverage area of the sprinklers shall be used instead of the S times L method. Let's review these requirements through an example. In this figure, there are 4 compartments. We will use the same hypothetical residential pendant sprinkler that we reviewed in the previous sections. We start our flow calculation with compartment 1. The area of this compartment is 400 square feet, and the sprinkler is installed at the center. The sprinkler can cover this room with a 20-foot by 20-foot coverage area. In accordance with the data sheet, the flow is 20 gallons per minute. On the other hand, since the area of this room does not exceed 800 square feet, the flow should be calculated by multiplying the average coverage area by the density of 0.1 gallons per minute per square foot, which results in 40 gallons per minute. Since this value is greater than the flow indicated in the data sheet, the minimum sprinkler flow is selected as 40 gallons per minute. The area of compartment 2 is 80 square feet. Since the bigger distance between the sprinkler and the wall is 7 feet, the sprinkler coverage area is considered to be 14 by 14 feet, and the flow based on the data sheet is 13 gallons per minute. The average coverage area of the sprinkler is calculated by dividing the compartment area by the number of sprinklers, which results in 80 square feet. Therefore, the calculated flow is 8 gallons per minute. In this compartment, the sprinkler flow shall be considered as 13 gallons per minute. The area of compartment 3 is 232 square feet. Since the larger coverage dimension for both sprinklers is 16 feet, the sprinkler coverage area is considered to be 16 by 16 feet, and the flow based on the datasheet is 13 gallons per minute. The average coverage area of each sprinkler is calculated by dividing 232 square feet by 2, which results in 116 square feet. Therefore, the calculated flow is 11.6 gallons per minute. In this compartment, the sprinkler flow shall be considered as 13 gallons per minute. For compartment 4, the area is 900 square feet. The sprinkler coverage area is considered to be 16 by 16 feet, and the flow based on the datasheet is 13 gallons per minute. Since the area of the compartment is greater than 800 square feet, the average coverage area method is not applicable, and the coverage area must be determined using the S by L method. The sprinklers are uniformly spaced in this compartment. The S is 16 and the L is 15 feet. This results in a coverage area of 240 square feet for each sprinkler. Therefore, the calculated flow is 24 gallons per minute. As we know, the sprinkler flow shall be the greater of 13 and 24 gallons per minute. Thus, the flow is taken as 24 gallons per minute. After calculating the minimum flow for all sprinklers, the pressure required to discharge these flows can be determined. For the sprinklers where the flow is equal to the value provided in the datasheet, the corresponding pressure can be taken directly from the datasheet. For sprinklers where the required flow is greater than the datasheet value, the pressure can be calculated using the equation Q equals K times the square root of P. In this example, the pressure for the sprinklers in compartments 2 and 3 is obtained from the datasheet, while the pressure for the sprinklers in compartments 1 and 4 is determined using the equation. The K factor of the hypothetical sprinkler is 4.9. Now that we have calculated the minimum flow and pressure of the sprinklers, we can begin the hydraulic calculation based on the 4 sprinklers that create the most demanding hydraulic condition. In our example, since the sprinkler located in compartment 1 requires the greatest flow and pressure, it will most likely be included in the combination of 4 sprinklers that produces the greatest hydraulic demand. As a final note, we should remember that NFPA 13 permits the use of the room design method for residential sprinklers to determine the number of sprinklers in the design area. We covered the room design method in a separate video.